Hello students, in the last session we have seen mesh analysis and mesh analysis by inspection method. In today's session we will learn nodal analysis. Let's start with nodal analysis. Now when we say nodal analysis, in an n node circuit, one of the nodes is chosen as reference or a data node, then it is possible to write n-1 nodal equations by assuming n-1 node voltages. So in other words, if there is a n node circuit, we will get n-1 nodal voltages and n-1 nodal equations. Now when we are talking about node voltage is the voltage at a given node with respect to one particular node called the reference node. And this reference node is assumed to be at zero potential. I repeat, node voltage is the voltage at a given node with respect to one particular node called the reference node assumed to be at zero potential. Let's see with an example. Consider this circuit. There is a current source I1. This is resistance R1, resistance R2, resistance R3, R4 and R5. This is node 1, node 2 and this is your reference node 3. Now if we redraw it and if we say we are only talking about node 1, this is your I1. We are considering node 3 as a reference node, so this will be node 1. So reference node is assumed to be at zero potential, therefore it is grounded, and this is R2. Okay, this is your figure B. So we are now calculating voltage at node 1 with respect to node 3. Similarly, in the second part we will be calculating the voltage at node 2 with respect to node 3. So let's start with the first part. Okay, before that let's show the direction of current. The current is entering this node and leaving from the other nodes. So this current I1 is entering and then at the node it gets split into two parts through R2 and R1. Now let's apply Kirchhoff's current law, that is KCL, at node 1. So when we apply KCL at node 1, the current entering is equal to current leaving. Current entering is equal to current leaving the node. So that's why we say I1. I1 is nothing but voltage upon resistance. So let's talk about voltage, the current at point node I1, so node 1. So over here what it will be? It will be V1 upon R1 plus V1 minus V2 upon R2. So I1 is equals to V1 upon R1 plus V1 minus V2 upon R2. V1 and V2 are voltages at node 1 and 2 respectively. This is with respect to node 1. Now let's see at node 2. Now at node 2, if we redraw the circuit, if we redraw the circuit with respect to node 2, we will get it as this is R3, this is R2, this is R4, R5. So at node 2, this is the current flow. We are assuming that the current is leaving the node. So over here, we can see at node 2, the current entering is equal to the current leaving. So let's write the equations. The equations with respect to node 2. So if you consider the node 2, it will be voltage at node 2 minus the voltage at node 1 upon R2, voltage at node 2 upon R3 plus the voltage at node 2 upon R4 plus R5. So if we rewrite it, the equations, it will be V2 minus V1 upon R2 plus V2 upon R3 plus V2 upon R4 plus R5 is equal to 0. So this is the KCL that is applied at node 2. So if we rearrange the equation, we get V1 into 1 upon R1 plus 1 upon R2 minus V2 upon 1 upon R2 is equal to I1 minus V1 upon R2 plus V2, 1 upon R2 plus 1 upon R3 plus 1 upon R4 plus R5 is equal to 0. This is your equation 1 from node 1. This is the equation 2 from node 2. This is how you solve the nodal analysis. This is how you find the voltages at node 1 and node 2. Let's solve another problem. Okay, take down the question. Write the node voltage equations. Write the node voltage equations and determine the currents in each branch for the network as shown. Consider this circuit diagram. Please copy the diagram along with me. Let's start solving the problem. We have to find the node voltage equations first, and then we have to find the currents in each branch for the network. Let's assign the node voltages first. So there are two nodes over here, V1 and V2. Let's write down the branch currents. So this is your current through 10 ohm resistor. This is your current through 3 ohm resistor. This is your current through 5 ohm resistor. This is your current through 1 ohm resistor. At the side, this current is flowing, gets divided at node 1, then again it gets divided at node 2. So applying KCL at node 1, KCL at node 1, what it will be? V1, current is nothing but voltage upon resistance. So voltage upon which resistance is there? 10 ohms. We are taking respect to node 1, right? So V1 minus V2 upon 3. And what is the current source that is given? 5. So it will be KCL at node 1 will be V1 upon 10 ohms, V1 minus V2 upon 3 ohms equal to 5 amperes. That is your first equation. That is your first equation. If we rearrange that first equation, we will get as V1 is 1 upon 10 plus 1 upon 3 minus V2. 1 upon 3 is equal to 5. I'll just mark this as E because we rearranged it. Now let's apply KCL at node 2. So KCL at node 2. How do you find the KCL at node 2? Again, V2. So it will be V2 minus V1 upon 3 ohms. V2 upon 5. V2, that is node voltage at node 2 minus 10 volts upon 1 is equals to 0. So let's write it down. So it will be V2 minus V1 upon 3 plus V2 upon 5 plus V2 minus 10 upon 1, that is equal to 0. This is your second equation. Let's rearrange the equation. So once you rearrange the equation, you get minus V1 1 upon 3 plus V2 into 1 upon 3 plus 1 upon 5 plus 1 is equal to 10. So let's solve it. So if we solve this problem, you will get 0.4 0.433V1 minus 0.3V2 is equals to 5 minus 0.333V1 plus 1.533V2 is equals to 10. Cross multiply so that we can eliminate V1 and find out V2. You end up getting so you get 0.5539V2 is equal to 5.995. So V2 is equal to 10.82 volts. That is your node 2 voltage. So what will be your node 1 voltage? Just substitute in one of the equations. So you get 0.433V1 minus 0.33 into V2 is 10.82 equal to 5. So V1 we are getting is 19.79 volts. That is our V1. They have also asked us to find out what are the branch currents. So we need to find out the branch currents. So let's find out the branch currents. I10 is nothing but V1 upon 10 volts. So that is 19.79 upon 10, that is 1.979 amperes. You can see I3, that is the current to the resistance 3 ohms, is 2.98 amperes. I5 is V2 upon 5, that we get it as 2.18 amperes. I1 is V2 minus 10, that is around 0.9 amperes. This is how you solve the nodal analysis problem. Let's do another problem on nodal analysis. Okay, take down the next question. Determine the voltages at each node. Determine the voltages at each node. From the circuit. Let's draw the circuit diagram. Have you all copied down the diagram? Okay, let's note down the voltages. Here there will be 3 voltages. Voltage V1, voltage V2 and voltage VP. So there are 3 nodes, 1, 2 and 3. Node 1, node 2 and node 3. Okay, let's start with node 1. At node 1, let's find the KCL. At node 1, we are assuming that all currents are leaving. Assuming all currents are leaving. So let's write down the equation. What is the equation now? It will be V1 KCL. KCL at node 1. So it will be V1 minus 10 upon 10. V1 minus 10 volt upon 10. 10 is the resistor. Plus V1 minus V2 upon 3 plus V1 minus V2 upon 3 plus V1 upon 5 is equal to 0. Hope you all have understood the equation. I'll repeat. V1 minus 10 volts upon 10 ohm resistor. Then V1 minus V2 upon 3 ohm resistor. Since 3 ohms both are in parallel, another addition, V1 minus V2 upon 3 ohms plus V1 upon 5 ohms is equal to 0. Rearranging the equations, what we get is V1 into 1 upon 10 plus 1 upon 3 plus 1 upon 5 plus 1 upon 3 minus V2 1 upon 3 plus 1 upon 3 is equal to 1. After solving, you get it as 0.96. V1 minus 0.66 V2 is equal to 1. This is your equation 1. Now let's find out at node 2. What will be at node 2? At node 2. At node 2, the KCL. Again it will be what? V2 minus V1 upon 3, V2 plus V2 minus V1 upon 3 plus V2 minus V3 upon 2 equal to, what is the current source? At node 2, 5 amperes. So let's write it down. So it will be V2 minus V1 upon 3. This is for first parallel branch. First parallel branch. Then it is V2 minus V1 upon 3 plus V2 minus V3 upon 2 equal to 5. So if you rearrange the equation, you get it as minus V1 into 2 by 3 plus V2 1 by 3 plus 1 by 3 plus 1 by 2 minus V3 half into half is equals to 5. So the equation after you solve, you get it at 0.66 V1 plus 1.16 V2 minus 0.5 V3 is equals to 5. This is your second equation. Now let's do at node 3. Now if you see at node 3, at node 3, what will be the equation? V3 minus V2 upon 2 ohms, V3 upon 1 plus V3 upon 6 ohms. So let's write down. V3 minus V2 upon 2 plus V3 upon 1 plus V3 upon 6 is equals to 0. So you get it as minus 0.5 V2 plus 1.66 V3 equals to 0. This is your third equation. Let's solve all these three equations using Cramer's rule. So, applying Cramer's rule, Cramer's rule. We'll find the voltage V1. We have solved. We have already know how to use Cramer's rule. I have taught you all in the mesh analysis session. So finally, you get 7.154 upon 0.887, that is around 8.06 volts. And to find V2, so V2 will be 9.06 upon 0.887 is equal to 10.2 volts, and V3 you have to be very careful with the calculations. If one value goes wrong, the whole problem will go wrong. So be very careful while solving. So V3 will be so finally we have got V1 voltage as 8 volts, V2 voltage as 10.2 volts, and V3 voltage as 3.07 volts. In the next session, I will be teaching you all nodal analysis by inspection method.